For the start of 9.4, we're going to be looking at fitting exponential models to data. So the question of the day is, how do you make an exponential equation based on a table? And this will be heavily reliant on using Desmos for the entire time, pretty much. And it will be able to allow us to get points on the table or points that we can plot on the graph, and then we'll make the line going through it. So for our first example, we have a little bit of an intro here. It says, after a person takes medicine, the amount of drug left in the person's body decreases over time. When testing a new drug, a pharmaceutical company develops a mathematical model to quantify this relationship. To find such a model, suppose a dose of 1,000 milligrams of a certain drug is absorbed by a person's bloodstream. Blood samples are taken every 5 hours, and the amount of drug remaining in the body is calculated. So what we have here is we have somebody who's going to be taking some drugs, some kind of medicine, and then over time they're going to be looking at the blood and seeing how much is left in the person's bloodstream over, I think, every 5 hours, it says. And then we have a little table for that. So for our first example, we have drug absorption data, hours since the drug was administered, the amount of the drug in the body in milligrams. So every 5 hours, so from the very beginning and every 5 hours on, we're going to be taking measurements of how much of the drug is still left in the body, and obviously over time it goes down. What we're first going to do is go back to our original exponential equation, which is normally f of x equals a times b to the x. And what we're going to do today is we're going to keep using this, but instead of using f of x, I'm just going to use the letter y in place of f of x. So I'm going to go ahead and write that down here. Y equals a times b to the x. Example 1, find an exponential model to fit the drug absorption data using the initial condition and one other point in the table. So what we're going to do is we're actually going to find the values for a and b, and in the end we'll have an equation we can use, and it will model all the data points that we have here. So first, let's go ahead and label the x and y axis. We'll say this is, or the x and y table. These will be the x values, these will be the y values. To find the initial a value, what we're going to do is we're going to pick the very first point here, which is 0, 1,000, and we're going to plug that in for x and y. So x is 0, it's going to go here, and the y value is 1,000. So it would be 1,000 equals a times b to the 0. And what's nice about this one is that any number to the 0 power is the number 1. So this whole thing here changes to the number 1. So it's actually 1,000 equals a times 1, or just equals a. So we found our a value. A equals 1,000. Part B, choose another point from the table. So some other point that's on here. And we're going to substitute in to find the b value. So right now we actually have y equals 1,000 times b to the x. 1,000 comes from the part A. Just plugging that back in. Down here, well, if I could read. Great. And we're going to pick another point on the table here. So I'll just pick the next one, but you can pick any of the points on here. It doesn't really matter. I'm going to do 5 for x and 550 for y. So we plug in 550 on the y side. The other side is 1,000 times b to the 5th power, because that's the x value. And then we're going to solve this for b. Both sides, we see that we have 1,000 times b to the 5th, so we're going to get rid of that by dividing both sides by 1,000. Also, if you don't know, you can go to Desmos and do these calculations. So if you don't have a calculator at hand, you can just type the stuff in. So if I did 550 and you hit the slash button next to the shift, divided by 1,000, it gives you the answer as well. So you can use this as a calculator as well, rather than just graphing part of it. So it's 0.55. These cross off. So we get 0.55 equals b to the 5th. Then if you remember how to get rid of a 5th power, you can do one of two things. You can take the 5th root of both sides, or you can raise it to the 1/5 power. So that's what I'm going to do. I'm going to raise both sides to the 1/5. Both sides, 1/5. And again, I'll just type that in Desmos so you can see what it looks like. So let's delete this one. So it'll be 0.55 then shift 6 to get the exponent, then 1 divided by 5. And it's 0.887. I'm going to round this number to, we'll do 0.89, round it up. So this would be 0.89 equals B. So now we have everything we need. We have a B value, we have an A value. Put this all together. So what is one model that fits all this data? We could say it's Y equals A value, which is 1,000, times our B value, which is 0.89, to the X. And the last thing we're going to do is we're going to check our equation that we just found. And we're going to plot the points on Desmos to see if it fits correctly. So I'm going to take these numbers here, the 0, 1,000, everything. I'm just going to pull off the side for now, and we're going to type those into a table. So on Desmos, you hit the little plus sign. It says table. Click on that. Type in all the points. 0, 5, 10, 15, 20, 25, 30. We'll go back over here. 1,000, 550, 316, 180, 85, 56, 31. Now, if you can't see all the points on your graph yet, that's because we just are not in the right window. So we will hit the magnifying glasses over here on the left. It says zoom fit. Click on that. Takes you to all the points. And on the next line, we will put our equation in, which is y equals 1,000, parentheses 0.89 to the x. And if you look and see, it should go through most of our points, and that should be our model, which is our exponential equation that we can use for this data set. So the question was, does your equation seem to fit the data? I would say so. It's going through all the points here. The only one it really doesn't hit is this one down here. But for the most part, it did a pretty good job. So, yeah. So now there's one for you to try. So you would delete the table. You would delete the table, delete the equation, start fresh, and do one for the team huddle. After that, we're going to move on to another example. We only have one more to do together, and I might show you number 3 as well, but that would be it. So we're going to do one more. Below the U.S. box office gross for the first 11 weekends of the release of the movie Mission Impossible 3 in 2006. Follow the steps below to fit an exponential model for box office gross based on the number of weekends the movie has been out using Desmos. So this time, we actually cannot use what we did in the huddle and in this problem here. Can't do the same format because we don't have a 0 amount. Like, we don't have an initial amount, whereas last time we were able to figure out what the starting value was, which was 1,000. So this time we don't have that because we start at the number 1. So instead, I'm going to show you how it works with Desmos and how I can do it for you. So we will go ahead and label this. Part A says plot points in Desmos using X for the weekend, so X, and Y for the US box office gross. So this is the number of weekends we have. As we count, usually the amount of money they make per weekend goes down as the movie has been in the theaters longer. So we're going to plot the points. Let's do that now. Move that over. Again, plus your table. Then we're going to go from 1 to 11. And on the other side, we have how much money they made. Okay, 7.0, 2. All right, I think I got them all. You can see the points this time, but if we want to see a better window of the points, let's hit this again. Okay, now we're in part B. In order for Desmos to make a curve of best fit to model the exponential function, type the line below. So we're just going to type this in, and it will actually take all the points we had, the x1s, the y1s, and it will create an equation by giving us the a and b values. So we're going to type in exactly as it says. It says y. If you just press the number 1, it puts the little 1 down there. You don't have to hit anything else. Then instead of writing equals, you're going to type the tilde key. That's shift, and it's the button right next to the number 1 on the left. Then we have a times b to the, so hold shift 6, x1. Again, you just type x then 1. So it actually makes the equation here, or makes the line, the graph, and gives us values for a and b. So that's what we're going to use. In part C, if you look at it, it says, under parameters, record your a and b values. All right, our a value was 91.717. We'll say the 91.2. And our b value is 0.52. So what was the equation for this set of data? If we were trying to use it as an equation rather than a bunch of points, we could say it's y equals our a value, 91.2, times our b value, 0.52, to the x. And then lastly, we'll actually use this equation now to predict how much money they'll make in the next week, the next weekend, I guess. It says use the equation to estimate the movie's gross in its 12th weekend. So we have 11 so far. We'll go up to 12. We're trying to figure out how much money they make. So it's just a prediction because we don't know yet. So we'll use our equation, y equals 91.2 times 0.52. Now this time, since we're trying to find out the 12th weekend, the row for the weekends stands for x. So we'll plug in 12 or x's and get our value. Now let's type it in Desmos and see what we get. So we'll delete that. Just make a new one. Y equals, not only y equals. It was 91.2 times 0.52 to the 12, I think. Yeah. Okay. So that gives us a very small number. I'm going to put a lot of decimal places in this case. So we're going to 0.0356479.8. That should be enough. The only reason I'm actually doing all these numbers here is due to the fact that this row is in millions of dollars. So this is 0.035 blah, 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 millions of dollars. So if we want to actually convert that to just how much money it is and not in millions, you'd multiply this by 1,000,000. All that does is actually move the decimal place over 6 times. So 1, 2, 3, 4, 5, 6. So how much money they made? They made $35,647.98. That's money. Now, normally you don't have to do that kind of step. It's only because I was trying to change it from being written in millions to how much money it actually is. The last one we're going to do is the team huddle. So you can do team huddle 2. There's a multiple choice. There's another one for you to try to type in. And there's one more. We're going to type this one in, and we're going to fit it to these 3 models, and then we'll be able to wrap it up. Okay, so I'm going to type in this table over here. Delete everything else. Table. Now we're going to go from 1 to 12. Okay. 539. Okay, 73. Oops. All right, let's go ahead and zoom in on these dots. So this one actually can be modeled by multiple equations. So on this example here, we're going to do exponential. However, it doesn't really look like it's that much of an exponential curve, unless it's a very elongated one. So there's multiple models we can use here. I'm going to try using multiple models in here. We have exponential. We're also going to try to fit it to a quadratic, which means you're going to get like a happy face, sad face. And the last one will be a linear model, which just means it's a straight line. So we'll do the normal one, and I'll put the equation on there. So we'll do y1 tilde a times b to the x1. So as you can see, it is exponential growth here. However, it may not look like it really is exponential growth just because, I mean, maybe it does. It's like it fits on the curve, but it's just such a wide curve. So we'll fill that in. It was 480. y equals 480 point, oh, I could say 481, I guess, right? And then times 1.063 to the x. So that would be one model. Does it seem reasonable? I mean, it goes through all the points, so probably. I'll say yes. The next model we're going to type in is this one. So I'll delete this one here. Do a new one. This one is y1, then the tilde key. So if you remember, we used to have the one where it says ax squared plus bx plus c. It's the same idea. It's ax1, got to square it. So shift 6 squared, plus bx1 plus c. So this is going to make a parabola out of the data points. So as you can see, if you zoom out, you can see the parabola. So all these points line up perfectly on here, pretty much perfectly. So this is another model you could use. So our a value is 0.94. I'm just going to go ahead and move this over and write it underneath. So the one equation we could also use would be y equals 0.94 x squared plus 32 x plus 470.6. And that would be a model you could use as well for this set of data. It's not always exponential that works. So this also goes through pretty well. Yes, it seems reasonable. And the last one we're going to do is a linear one, where it's just going to draw a straight line through it. So I'll delete that one, and we'll do y1 tilde mx1 plus b. You should be familiar with y equals mx plus b. It's the same idea. This one isn't as great because it's a straight line, and it goes through a decent amount of points, but I don't think it's as good as the other ones. And so our answer we got was 44 for m and 441 for b. So this would be the equation y equals 44.5x plus 441. We'll round that up to 42. And this one is just kind of, does it seem reasonable? I think it does seem reasonable, but it's like just not the best. So this is a straight line going through all the points. So regardless, it doesn't matter what model you type in here. This one actually could be like all three models, but depends on which one you're trying to look for and how the data trends, maybe even more than that. So you have to kind of maybe figure out which one will be best. So that's just an idea of how to do not only exponential, but also quadratics and linear models where you have straight lines. You know, this is always going to give you like a straight line one way or another. This will always give you like a happy or sad face. And then up here, we're looking for, the exponential growth like that. And that's all to this lesson. It's really not that long, not too terrible. Make sure you finish the rest of these. And I believe the homework was, I don't have it open. It was 9-4B, the front page. For 9-4B, the front page only. Not the back. Oh, wait. There's only one page. It should be the back of the notes. But yeah, it is the front only. On Teams. And that's it for 9.4.